So basically, sintering is a process in which the green compacts are heated in a controlled atmosphere furnace to a temperature below the melting point of the metal powder, but sufficiently high. This temperature should be sufficiently high to allow the bonding or fusion of the individual particles to impart strength to the part. Okay, so what is happening in the sintering stage? You have a you have a big furnace, which is basically a belt furnace of very big size, and your powder metallurgy parts are placed on a belt which goes inside a covered furnace area, and it has a different zones. In the first lecture, I have given you a brief discussion about the sintering furnace, that it is comprised of different heating zones. So first we'll have a preheating zone, then we'll have a main heating zone, and finally we'll have a heat treatment zone. So what we are doing here, we are basically heating the powder metallurgy compact below the melting point of the metal, which is in the powder form, which was in the powder form. So we are heating the powder particles, and then we are promoting the bonding with the help of this diffusion process. And this temperature is basically carried out in a particular temperature zone, so which is basically this is basically a 0.7 times to 0.9 times of the metal's melting point. Okay, so in this figure we can see here that this is our green compact, and in this green compact we now we have capped this green compact into our sintering furnace, and slowly it will develop some sorry, this up to this here we have developed the this is basically your you can say the green compact, and then you gradually you have applied the sintering temperature, and slowly at the particle surface or the circumference periphery, small necks will be developed due to the diffusion of the atoms, and gradually the pore size will decrease, and finally the particles will fuse together, and they will form a predefined grain boundary. Okay, and there are basically three mechanisms of sintering, or the three types of sintering. The first mechanism is the diffusion or solid state sintering. The second mechanism, or you can say the type, is vapor phase sintering, and third is your basically liquid phase sintering. So and all these sintering processes, suppose this solid state sintering and vapor phase sintering depends upon the applied temperature. So if your temperature is low in the range, then it will promote the solid state sintering, and which is basically your diffusion sintering. So in the first figure you can see that there are two powder particles, and they are closely packed, or you have deformed powder particles, and then you have applied the sintering temperature. So slowly the neck formation, there is a neck formation by the diffusion, and in the final stage the distance between the particle is decreased, and the particles are bonded together with the help of the diffusion process. And this is happening at the lower sintering temperature. While in the vapor phase sintering, you are actually working close to the melting point of the metal, and here in this case the particles, the temperature of the temperature at the surface of the particle is relatively high, which promotes the formation of the vapors on the surface, and through this vapor phase material transportation is happening, and the particles are bonded together, and relatively no shrinkage or less shrinkage is obtained or observed in this case. So this is basically the difference between the diffusion sintering and diffusion or solid state sintering and vapor phase sintering. And the main difference is the working temperature range. So where you are working, if you are working close to the vapor, you can say close to the melting point, then it will promote the vapor phase sintering. And if you are working below the working at the lower range, then it will promote the solid state sintering. We have already discussed that in the vapor phase sintering, the material is heated close to the melting point, and metal atoms will be released to the vapor phase from the particles. And at the convergent geometries, that is at the interface of the two particles, the melting temperature is locally higher, and the vapor phase is re-solidified as the temperature is reduced. And in case of liquid phase sintering, basically it occurs when you have powders of different materials. In the powder compact, you have a different powder material composition, and in this case, how you decide the sintering temperature? You decide the sintering temperature of that metal which has lower melting point as compared to the other metal. So in this case, the alloying can take place at the interface of the two particles. If one of the particle has the lower melting point than the other, the particle will melt, or you can say plastically deformed. And because of the surface tension, you can say in this particular figure, you have two different material. One is suppose A metal and other is B metal. And if you have applied the sintering temperature, so this particle having the lower melting point, it will surround, or it fills the space between the particles having the higher melting point. And because of the surface tension, it surrounds the particle which has not melted, and causes the diffusion of the particles, and alloy formation takes place. So basically, this is your liquid phase sintering. So we have discussed about all three types of sintering process. This table gives you an idea about the different temperature ranges and what should be the sintering time, because you are not interested in basically putting your powder compacts into the sintering furnace for longer time duration, because it will unnecessarily result in the wastage of the power energy, as well as it may lead to overheating of the particles, and which may lead to the deformation and distortion after the cooling. So you have different temperature ranges for iron and iron graphite. It ranges from 1000 to 1150 degrees centigrade, and the temperature and the time is basically you can say is ranging from 8 minutes to 45 minutes. And why this time is changing? So time is basically sintering time depends upon the thickness or the size of the parts to be sintered. Okay, so this is a schematic diagram of your sintering furnace, and as I've already told you that this is a belt type furnace, and it's a very long furnace which has three different zones. So first zone is your preheating zone, second zone is your sintering zone, and third zone is your cool down or heat treatment zone. So from this side, you are feeding your compacted specimen, and then first it heats. It goes to the preheated zone. So in the preheated zone, why you require preheating? So firstly, to minimize the thermal gradient, because from room temperature, and if suppose if your compact is at the room temperature, and directly if you are feeding into high temperature, so it will result in setting up of the thermal stresses inside the material, and which may lead to the cracking and deformation. So initially you need to heat it slowly, and in the preheating stage, whatever be the binder, whatever be some additives you have added in the powder metallurgy compact, all these additives, they will burn off easily, and it will not pose any porosity and other defects in the actual sintering stage. So from in this second stage, which is the sintering stage, you maintain the temperature, required temperature as per the table given in this slide, and then you keep it there for the required time depending upon the thickness and the size. Then from there, your this is basically computerized controlled machine, and you control the timing, you can control the speed of material flow inside the furnace. And this sintering furnace, and after the sintering process, when the material has achieved the proper bonding, then you send the particle, you can say your compact, into the this heat treatment or the cool down stage, where it is gradually cooled, not suddenly cooled. Again, after the sintering process, if you put your powder compacts into the atmosphere, again it will result in the setting above the residual stresses, thermal stresses, and it may result in the distortion and cracking in the material. So slowly cool down it. Or suppose if you have some steel compact, so in the steel compact, and if it has some carbon content, and suppose if you want to develop some strength, so in the cool down stage, though whatever be the heat treatment process you want to apply, you can apply easily in the cool down stage, and then your material will acquire the required strength in the cooled down stage. So the temperature gradient you can see here, the how you increase the temperature, gradually you increase the temperature, and then gradually you decrease the temperature in the cool down stage, and then you can perform your any type of heat treatment in which you are interested to impart the required strength and the property inside the in your part. So, if you like the video, then please subscribe to my channel, share it with your friends, and don't forget to hit the bell icon for the latest updates. Thanks for watching my videos.